They are the smallest units of the plant kingdom, isn't it? Why do we put algae in plant kingdom? Any idea? Have you heard of blue-green algae, Spirulina? We'll start from something that is familiar to you. No? Cyanobacteria or blue-green algae, they are the smallest microorganisms that are available in our plant kingdom. Okay? So microorganisms we say because they are not visible to the naked eye. Okay? Only under the microscope we are able to see them. But all algae are not microalgae. Okay? There are macroalgae. They even form forests under the sea. Okay? They are huge kelps and all that you would have heard. Okay? So those are macroalgae. And in the ponds you would have seen filamentous ponds. Wherever water gets stagnated, you will see that greenish color, isn't it? So commonly bryophytes and algae, in Malayalam we say fire, isn't it? So bryophytes and are included. Some bryophytes are included when we say fire. That is a common term that we use. Algae are wherever there is moisture content, we can find algae. Even on the walls you would have seen greenish color, isn't it? What do you think? Is it algae? Yes. Last year, I think Stephenson's student had done a project. On the 9th floor of a building, there was a small greenish patch. Okay, so that was studied and it was found to be possibility and 4 forms of microalgae are present there. Okay, so anywhere there is little moisture, there will be algae present. Okay, so these algae they are said to have been there from the origin of the earth itself. Okay, because from when life began on earth, oxygen is the most important component, isn't it? So these blue-green algae or cyanobacteria, bacteriologists actually put them under bacteria because they have prokaryotic kind of cell organization. I hope you know what is prokaryotic and eukaryotic. In school we have studied, prokaryotes and eukaryotes. So prokaryotes, they don't have any cell-bound organelles. There are no cell membranes. One major character of plants are the presence of the cell membrane, cell wall, isn't it? But these algae, because of the presence of chlorophyll and because they are autotrophs, they photosynthesize, we include them under algae. Okay, so bacteriologists still consider them as bacteria. That's why they are called cyanobacteria, but they show photosynthesis or they are photoautotrophs, hence they are included under algae. Now, this is a general picture about algae, and among these algae, total there are macroalgae which are visible, and microalgae, there are different groups of microalgae depending on the pigments and the chloroplasts that are present in it. In algal identification, there are 3 characters that we consider. One is chloroplast, the pyrenoid, and the pigments that are present in it. Okay, the shape of the chloroplast, the pyrenoid, shape of the pyrenoids, and the pigments that are present in. Based on that, we classify them cyanophytes, chlorophytes, and chlorophytes. Okay, these are studying the classification. I'm going to the details of it. So coming to cyanophytes, they are one of the most primitive forms, and I told you their major function is the release of oxygen. So oxygen is very, very essential for us. So when the earth was cooling down, okay, as the cooling down happened, water was present, and in that water the first plants that were formed are these said to be cyanobacteria or the blue-green algae. So they started photosynthesizing and releasing oxygen, which was a major reason for the other life forms to develop on the earth. Okay, so cyanobacteria airflow chamber. Okay, so the nichrome rod is used. microorganisms. Under the laminar airflow chamber, there is aseptic condition. You wipe the laminar airflow chamber with alcohol, and then rub your hands also with alcohol, and then you clean the surface, and then use this rod to streak the other plate. Okay, so then once you lift and start the streak, there will be more concentration. So from that you again dilute it. Third streak will be less dilute. Fourth streak will be less dilute than that. Then the fifth section 4 you can see dots are good. So when it grows, there will be more algae towards. So possibility of getting a single cell or single colony is there. Those dots are present in section 4. Okay, so that is the streak plate method for culturing and isolating this. Okay, understood how isolation and culturing is done? Now large scale production of spirulina is done by using different types of photobioreactors or in open ponds also. Tropical climate. Not well. So the raceway pond is a huge pond like show you the structure. In tropical countries we use this raceway ponds. Even in laboratories they have a small pond like setup. Okay, the small thing which is made of plastic. We call it as a raceway pond because of the shape. It is like a U shape. In tubular photobioreactors are there. You get the biomass. Biomass is the large amount of algae that you get from this after cultivating. Okay. Then flat plate bioreactor and column photobioreactor. See, this is the raceway pond that I told you. The lower picture. No? The other one, the next one is the closed photobioreactor, and then the upper part you can see how harvesting is done. Filtration to remove the algae, they do filtration. Okay, you can see that lady is filtering using a cloth. Okay, and that is dried. You see the next slide there. It is on a sheet-like structure where water can flow through. That kind of a setup they have for drying this. Okay, so the vitamins and minerals. Why spirulina is so important is because of the phycocyanin. Pigments are present in it. Phycocyanin is the pigment that is present in blue-green algae. Okay, so it gives the blue color. Then spirulina contains 55 to 70% of protein by weight. That's why it is an excellent protein source. Okay. Now it contains 15 to 20% of carbohydrates. The amino acids, it contains 8 essential amino acids and all the 10 non-essential amino acids along with linoleic acid, gamma linoleic acid and beta carotene. Then it is rich in vitamin B. It is all types of vitamin B, thiamine, riboflavin, nicotinamide, pyroxin, folic acid and cyanocobalamin along with vitamin C, D and E. Then the essential minerals like iron, calcium, magnesium, manganese, phosphorus, potassium, selenium, sodium and zinc. All these are present in spirulina. That's why spirulina is so important. It has a high nutritive value. So antioxidant and anti-inflammatory properties of spirulina. You can see that in that bottle it is C-phycocyanin. Nowadays we go for natural coloring products, isn't it? Because the artificial coloring products we use a lot of chemicals. So this phycocyanin is used for getting the blue color. Okay, they extract the blue color. Then red is obtained from hematococcus. Red color is obtained from hematococcus. Okay, so this helps in because of antioxidant property of phycocyanin in the anti-inflammatory properties and inflammation. Why is inflammation first? Inflammation, isn't it? So why do you think inflammation happens? Zoology. sports. In African countries where food is very very scarce, okay, wherever there is water, algae are available. So they take that and dry. So you will see the number of proteins and carbohydrates and amino acids that are present in that. It helps those people to get their daily nutrition, daily requirement of nutrition. Okay? And that's why dietary supplements, and it is also highly recommended as an immunity booster. This is not recommended for patients with autoimmune disorders. What is autoimmune disorders? Yes, I can have നമ്മുടെ ബോഡിക്ക് എതിരെ തന്നെ പ്രവർത്തിക്കുന്നു. അപ്പോൾ when autoimmune disorders, when already a person has autoimmune disorder, if they take spirulina, again it boosts their immunity. So it will lead to complications. And pregnant women also, they don't advise because high immunity will cause some antioxidant. When the child's blood group, there is incompatibility, it causes complications. These are the products that are available from Spirulina. You can see pasta with Spirulina. They make pasta, green colored Spirulina pasta you get. Then Spirulina tablets and capsules. You know, olden days when food was scarce during World War time, they used to distribute Spirulina capsules, basically tablets or Spirulina capsules to the soldiers. And you can see the product, other crunches and chocolates. Bioprinting of chocolates is done in China. Chinese always have innovative ways. Chinese food, sushi, have you heard of sushi? That is also, they make use of algae. Have you tasted sushi?
Yes.
Sushi, and what is the other one? One more thing is there, sushi and? How do they make sushi? Have you seen?
Yes.
Reels of the how do they make sushi? Algae is made into sheets. Okay, these sheets, they boil the rice and then they color the rice in different colors, pink, violet, orange, and some make it white. Then they spread these sheets and ഓരോ ലെയറിൽ നിന്ന് 4 കളറിലെ റൈസ് വെക്കും. എന്നിട്ട് പച്ച മീൻ, നീളത്തിൽ മീൻ കട്ട് ചെയ്തിട്ട് അതും വെക്കും. എന്നിട്ട് ഈ ആൽഗെ ഷീറ്റ്സ് ദേ റോൾ. When you roll, you get that. ഇങ്ങനെ റോൾ ചെയ്തിട്ട് പല കളറും അടുത്ത ഫിഷിന്റെ പിങ്ക് കളർ. They slice it, they put it into the broth. പച്ച മീൻ and this algal sheet also has a fishy taste, fishy smell and taste. Not spirulina, but this seaweed. Okay, what is the environmental impact? You see, this is the you can see a desert. It is a desert that they are cultivating. Actually, in Abu Dhabi, King Abdullah University, they have a huge setup of algal culture. Here, plants won't grow. But you see, this algae has high carbon sequestration rate. So imagine this much of field, algal fields can absorb so much of carbon dioxide and release so much of oxygen. So in a desert condition, this is very, very essential. So it has a high environmental impact. So it leaves low environmental footprint and it is an efficient resource use because very less water is required. Okay, and that water can be reused. Okay. The spent medium after filtering the spirulina, that spent medium can be used as for watering plants. It is very, very good for plants because they contain all the nutrients and ease of cultivation. Okay, relatively less contamination, relatively less because all the other algae in culture, if we are culturing chlorella or different other semi-resins and all that, it gets contaminated within 4 or 5 days. There will be contamination. Okay, whereas spirulina, because it grows in such high pH, okay, products ranging from smoothies, energy bars, all those. Because the proteins, high protein content is present there. You can use it in energy bars and cosmetic and skincare products also. We have spirulina because it is rich in antioxidants and skin rejuvenation, and also the natural ingredients that are present are beneficial in use of cosmetics. The research that is going on current is needed for spirulina to be enhanced as a product is investigating spirulina's ability to treat allergies and immune disorders. Like ethnobotanical is people treat with plants, isn't it? The same way using spirulina also to treat inflammation. When there is a wound, they apply spirulina powder and this inflammation and the wound heals very fast. Okay, but there is no research work that has happened. What is the component in spirulina that is making this inflammation to go? We haven't organized. So research is required in highlighting the therapeutic potential of spirulina. And in cancer research also, it has large applications in oncology, but research is happening to find out what are the antioxidants or what are the potential chemicals that can be used, or how the action of it happens. Then immune system support. Spirulina enhances immune responses, making it a subject of interest in immunology research. The current challenges is contamination issues. This contamination is a significant challenge in spirulina production, which affects product safety and quality. I showed you that the desert, they have huge fields, isn't it? So there, if contamination occurs, the whole product will be contaminated. So you have to be very, very contamination not only from algae, but bacteria, fungus also contamination will happen. So they have to monitor it on a large scale. You can produce on a large scale, but minute monitoring is required. Then quality variability, that is spirulina. During harvesting or during cultivation, if there is some contamination, it is not, the quality is not checked properly, the product replicated as tablets or capsules. If it contains contamination, then the person who consumes the tablet will get other disorders. So we cannot say it is the disorder is because of spirulina, maybe because of contamination. Controlled growing conditions, which requires specific controlled growing conditions, which are essential to maintain the optimal environmental practice. Recently, advancement in cultivation techniques have increased the efficiency of spirulina production. The bioreactors are being used to scale up the production, so that open systems, because of threat of contamination, we use closed bioreactors. And then efficiency is also making way for market growth. The future prospects in market growth is because of the rising health consciousness among consumers. We always go for natural, isn't it? Organic vegetables, natural skincare products, everything we go for natural things. But we eat a lot of junk other than that. Always natural products have a market. Then sustainable food demand. It is eco-friendly source of nutrition and global popularity. I told you about chocolates, bioprinting, or all those things. When something new comes up, they always like to write. So that also is market. In India, there are different journals which are there for all over the world. There are almost 600 industries which are producing spirulina, and they produce these journals where they give about all the details on about each fortnightly use of spirulina. Here we can see the early cultivation in India, Karla village, Murjapur Research Center, New Ambadi Estates, Antenna Trust, Simplicity Spirulina Farm. There are many farms are there. These are the references.